All right, the last problem on acceleration, velocity, and position. And this one's a little more involved. Okay, so let's start with part A. So it says write an expression for velocity in terms of t. So in this one, we know they gave us acceleration, but we know the derivative of velocity is acceleration, which is what they gave us, 6t minus 18. So that means that v of t is got to be 3t squared minus 18t plus c. Okay? And then they gave us this initial piece right here. So that means if I plug in 0 for t, and we get 3, and this is 0 squared minus 18 times 0 plus c, it has to equal to 24, which means c is 24. So my velocity equation is therefore this. Same thing, but the constant is 24. So that's part A. Now it's asking us to write an expression for x of t. And again, basically the same thing. Part B, the derivative of position is velocity. And we just found our velocity equation, which is this. So to find x of t, we find what gives us this derivative, which is t cubed minus 9t squared plus 24t plus some constant. Okay? And then they gave us the fact that at x at time 1 has to be equal to 20. So we plug in 1. So this is 1 cubed minus 9 times 1 squared plus 24 times 1 plus c has to equal to 20, which means c equals 4. So again, we come back over here and we plug in 4 for c, so we get this. And that's our position equation. Okay, so A and B really easy. Part C, it says determine the times where the particle's velocity is 0. Easy. We already know the velocity equation. So we just find its zeros. So V of t equals 3t squared minus 18t plus 24, set equal to 0. You get 3, and this is t squared minus 6t plus 8. And then when you factor it, you get t minus 4 and t minus 2. So my zeros are at time equals 4 and time equals 2. That's it. That's part C. Now, part D says describe the motion of the particle from time equals 2 to time equals 4. Okay? And indicate both direction and distance. Okay? So part D is the more involved part. Okay? So let's talk about its direction. So again, I'm going to set up for part D a number line, put in 2 and 4. This is, I'm testing my velocity. Okay? So the velocity at time 0 is positive. At time 3, it's negative. And at time 5, it's positive. Okay? So we're going, it's first moving to the right, then to the left, and then to the right. So between time 2 and 4, it's moving to the left. Okay? Also, we're going to find x of 2, which is 24, and the position at 4 is 20. So we know it's moving left. Okay? Also, what I'm going to do is I'm going to look at my acceleration, and the zeros are at t equals 3. So if I look at my number line here, I'm going to plug in 2 for a very specific reason. I get negative, and I plug in 4, I get positive. Okay? Which means that from 2 to 3, my velocity is decreasing. And from 3 to 4, my velocity is increasing. Okay? So if I wanted to use this information to kind of graph what we have, at time equals 0, I'm at 4. At time equals 1, they told us that we were at 20. At time equals 2, we just did it when we're at 24. Then 3, 4, at time equals 4, we're back down to 20. And so our graph looks something like this. This is a maximum, then it comes down, minimum, and then it goes back up. This is what my graph looks like. And you can see that since this is my maximum point, it goes up and then down, and this one goes back down and up. But since it's coming down here, this is going to the right, to the right, to the right, this is going to the left. But since my acceleration and my velocity here are the same, it's speeding up. But then right here at 3, it starts slowing down and then turns the other way. Okay? So just the way these all relate together makes a big difference. So the answer to part D is that it's moving to the left, and it starts at 24 whatever units and then goes down to 20.